This lesson is going to be about hypothesis testing of a proportion. We're going to use the p-value to make a decision to reject the null hypothesis H0 or fail to reject the null hypothesis H0. I'm going to show how to do this using the TI-84 graphing calculator. And I have two of them here because the entry is done differently with the calculator based on the model of TI-84 you have. The p-value method can be used to make the decision about the null hypothesis, H0, by comparing the p-value to the significance level alpha. The p-value is based upon the sample statistics, which are used to calculate the test statistic. The p-value is the area beyond the test statistic in the tail or tails of the normal distribution curve. The p-value is the probability that a random sample will produce a result such as the one in the hypothesis test if the null hypothesis is true. If the p-value is less than or equal to alpha, then the decision is to reject the null hypothesis. If the p-value is greater than alpha, then the decision is to fail to reject the null hypothesis. The p-value is the area in the tail or tails of the normal curve based on the test statistic and is found with the TI-83 or 84 calculator by using normal CDF. When the calculator is on, press second variables to get to this feature of the graphing calculator. Normal CDF is option 2, and when you press enter, this version of the calculator is ready for the values to be typed in. Again, it's option 2, but with this version of the calculator, you type in the entries of the lower or left value of the region of the area, then the upper value of the area, leave the mean and standard deviation as they are, and then hit enter or press enter to paste the entry onto the calculator. We're going to go ahead and clear off the screens of the calculator for right now so that we can do an example. For this example, we've got a test statistic of z equals 2.18. Remember that with a proportion, your test statistic is a z, and we use normal CDF. Our claim is that p, the population proportion, is greater than 0.38. Step A is to identify the test as right-tailed, left-tailed, or two-tailed. The greater than symbol points to the right and is always the case of the right-tailed test. So that's the situation we have here. A less than symbol is a left-tailed test, and a not equal to symbol is a two-tailed test. We're going to find the p-value. This means we want the area in the tail based on z equals 2.18. This would be considered the lower or left value of the area of the tail, and farther out to the right, we could use the value of 99.99 as the upper or right value of the area. So we're going to do this with both versions of the calculator. This is the older version where you just type it in. So, second variables, press 2 to get normal CDF, and the entry is normal CDF going from the lower of 2.18 to the upper of 99.99. You don't need to type it in, but you can put in the default values of the mean of 0, that's mu, the mean, and the standard deviation of 1. So 2.18, the comma is above the 7, 99.99, comma, 0, comma, 1. Press enter. So this tells me that the area of the tail is 0.014628, and so on. We can round to 2 or 3 decimal places based on what's requested in the problem. We're going to go ahead and round to 3 decimal places. So that 4 will turn into a 5, and we have a p-value of 0.015. Right, let's repeat that with the other version of the calculator. Second variables, option 2 for normal CDF, our lower value is 2.18. Our upper value is 99.99. You can see the mean and standard deviation are default values in the calculator. So we scroll down to paste, press enter, and you can also see that now on the screen is the exact same entry that was typed into the older version of the calculator. So we press enter, we get the exact same thing, and our result is again a p-value of 0.015. Now what we want to do is compare the p-value to alpha, which is 0.10. When the p-value is less than or equal to alpha, the decision is to reject the null hypothesis, and when the p-value is greater than alpha, the decision is to fail to reject the null hypothesis. When we have our p-value of 0.015 compared to our alpha of 0.10, we see that 0.015 is much smaller. So we have the first case, which is that we will reject the null hypothesis. All right, we're going to do another example to show a different one of the 3 possible cases. Again, this was a right-tailed test with the greater than symbol. So we're going to do another example of a different version of the test. I'm going to go ahead and clear out both my calculators also. Clear and clear. So for this next example, we have a test statistic of z equals negative 1.93. And we're going to be testing the claim that p equals 3/5. So we need to know if the test is right-tailed, left-tailed, or two-tailed. For a claim of p equals 3/5, the complementary symbol to the equal sign is not equal. So from p not equal 3/5, we have a two-tailed test. we're going to find the p-value. We had a test statistic of z equals negative 1.93. So we're going to find the area in the left tail. But because there's two tails, p will be 2 times that area. So if we're working on the left side, our lower or left value is negative 99.99, and our upper or right value is negative 1.93. So again, what we're going to do is go to normal CDF, and we'll be going from negative 99.99 up to negative 1.93. And again, we can type in our default values of a mean of 0 and a standard deviation of 1. So on the older version of the calculator, second variables, 2 for normal CDF. When typing these in, make sure to use the negation button, not the subtraction button. So, negation, 9999, comma is above the 7. Negation, 1.93, comma is above the 7. Mean of 0, comma, standard deviation of 1. So we get an area in the left tail of 0.02680, 0.02680, so on. But to get the p-value, we need to multiply that by 2 because there are two tails. So you can just, in the calculator, press the multiply key and then press enter. So we're going to do times 2, and we get a p-value of 0.05306, so on. Again, rounding to 3 decimal places, we get a p-value of 0.054. Let's repeat it with the other version of the calculator. Again, second variables. Normal CDF is option 2. Our lower is negative 99.99. Again, make sure you use the negation button. Our upper is negative 1.93. Our default values are fine. We paste that onto the screen to see the same entry we typed into the other calculator and press enter. So again, we get our area of 0.0268. Because it is a two-tailed test, we double that area to get the p-value and round to 3 decimal places to get 0.054. Now we need to look at our decision. Right, so again, we want to compare the p-value to alpha, which in this case is 0.01. If p is less than or equal to alpha, reject the null. If p is greater than alpha, fail to reject the null. P is 0.054. Alpha is 0.01. We can see that at the second decimal position, the 5 is definitely larger than a 1. So this is the situation where the p-value is greater than alpha, and we would fail to reject the null hypothesis.